Thank you so much for joining this channel. So we are in day 15 now. So in the day 15, we are focusing on the performance of the AI agent. So when I say performance means definitely right when you are building up any solution or any product, first we check whether the product is working or not, whether it is working as per the expectation of the requirement or not. But when everything is working fine, then we check the non-functional area, right? The agent actually performing with the best performance, or there is some slowness or some other activities. We will look into that area in the day 15. So as I mentioned, the .NET Semantic Kernel and Olama we are using. Olama has some challenges because when you are doing at the higher level, right, it is not performing as per the expectation. We have to change the code. But after day 15, we will focus on the cloud level so that it can perform better. However, just focus on the learning. So what we are doing actually in terms of performance, we are looking into the caching, parallel agents. Can we execute some independent parallel agents if we are not dependent internally, or can we use streaming for getting the response? Can we optimize the token? The more the token you will send to the Olama, it will be costly also, and it will take time also. So these are the things already we are using in the normal application, caching and everything, the same concept, but this token optimization is a new thing. The remaining, I think, all we have used in somehow in some other projects. So why performance optimization matters? So agent can become slow, right? We don't know the agent is slow, the LLM is slow, or any tool which is working for getting the extra information is slow. So you already introduced the observability, right? So that will give you the execution time. But apart from that, what else we can improve in terms of optimization? So optimization reduces the latency, LLM token cost. So whenever you would build anything, we have to check the costing part also, right? So make AI agent faster, cheaper, and scalable. So any project, forget about AI agents, always try to make it scalable, faster, and cheaper. That is the objective, business objective. So the same concept applies in the AI agents also. So we introduced. So what we will do, we will do prompt catching, we will do parallel agents, streaming response, and token optimization. These are the four KPIs we will focus on in terms of optimization. So these are used in the real AI agents. And when you go to the OpenAI, Azure AI Foundry, LangChain, it will be like a similar concept will work over there. So key optimization technique, as I mentioned in the previous slide, these are the four areas we will check, and we will show into the demo also how we can achieve that. Just remember these four pointers. So prompt catching. What is prompt catching? You are executing a prompt, right? You have multiple agents. The same prompt you have to execute again, right? So you can store into the cache, right? And then instead of calling the LLM or something, you can use the cache details, right? So avoid repetitive LLM calls for identifying identical prompts. So the prompts are almost same. Store previous responses in the cache. So parallel agent execution. So prompt caching we discuss. Parallel agent execution means if there are multiple agents and all are working independently, we can use it a parallel concept. And you know that multi-threading has a concept of tasks.when all. So when all will ensure when all the tasks complete their work, then only this tasks.when all will be passed. So that we can use for parallel execution, and reduces the total response time. So if it is each individual agent take 3 seconds, so suppose there are three agents, so 3 into 3 9 seconds. But at the same time, if you use this tasks.when all, so in the 3 seconds, all three will work parallelly. So that is the reduction in over the response time. Streaming response, stream token from the LLM to user interface. LLM also respond, right? So that will be sent in the stream format, improve the perceived performance. Token optimization, trim long code. You are sending huge code. Sometimes you say, right, it is a huge code, reduce it. So try to send the exact code or whatever you want to send it to the LLM before. Then you just do some validation kind of thing that you can achieve using the day 4 also, where we are using not only we are depending on the LLM, but we have our external validation logic which you can enforce before sending to the LLM. So that can cover in the day 4 also. And it will say, so you do know, the more the number of lines, more the number of paragraphs, definitely the token size also get increased, and latency also, so the cost also. So many things are involved, financial also, and also performance. We have to look into that. So performance architecture. So user will send the request, token optimizer will first check that input, what is the, then we will use the cache, and then the cache means the prompt caching that we discuss. Then the parallel agent will be called parallelly, and then the LLM will be called from the individual agents. And once the LLM get the response from the multiple agents, it will be sending back the responses in the streaming format to the back to the user interface. So this architecture reduces latency, token cost, and response time. Response time, why? Because we are executing at the in the streaming format. Token cost, why? Because we are using token optimizer, and that also reduces the latency. So user request. So the same thing we have just put into the diagram. What is the benefit? Faster response, lower LLM cost, better scalability, production ready AI agents. So in the day 15 become a major milestone. We are using AI runtime. We will use runtime orchestration, parallel agents, caching architecture, and agent routing also. So whatever we have learned in the previous days, the routing and on the orchestration, we already done that. But in addition to that, we are using the parallel agents and caching. So performance improvement, prompt cache. Definitely, if you do the prompt caching, avoid duplicate LLM calls. If you do run parallel agents, the overall execution time will be reduced. If you are using streaming the responses from the LLM, it will be faster perceived response. And token optimization, it will lower the cost to the LLM, because when you use the Azure Cloud Foundry or any cloud, definitely there will be a cost associated with that. So you have to, if you know the optimization technique, your overall cost will lowered. And in day 16 we will do something, but I hope you understand. Before day 15 what we have done from day 9 to day 14. Now our AI system is multi-agent tool uses. We have already introduced structure, output, telemetry already introduced. Now we are introducing this, so it is almost similar to the LangChain runtime, CrewAI orchestration, Azure AI Foundry, agent pipeline. So almost we are reached to the enterprise level, or you can say mini AI orchestration framework, where we are using the parallel agents, orchestrator, runtime, everything will be there. Along with that, we can couple the functionality that we discussed in the previous days, like day 1 to day 14. So let's move to the details. So technology stack, it is almost same what it is we are using from the day 0 to day 13 14. The technique we are using: prompt caching, parallel agents, streaming response, and token optimization. These four area we are covering up, that we already discussed in the PPT also, and we will do some deep dive also here. So this already you have that from day 9 to day 14 what we have done. Now our AI agent is more have multiple features, but here performance was still not covered right till day 14. So in day 15 we are covering the performance part. So why performance optimization is important? So AI becomes slow, right? AI system expensive also if you are not getting the response. So common issues are high latency, repetitive LLM call, larger prompt, or maybe the semantic kernel itself is a timeout, or maybe the larger prompt, or maybe the LLM is not functioning well, or high latency. Maybe you are doing sequencing executions, overall response time getting increased. Anything can happen. So without optimization, slow response, and high LLM cost, poor scalability. So optimization technique, we introduced four major performance technique: prompt caching, parallel agent execution, streaming responses, token optimization. These techniques are used by enterprise AI platform. So prompt caching avoid repetitive calls. So you can see without caching it is agent to LLM to response. Now it is agent to cache then response. So before hitting the LLM it will check the cache. It reduces the latency and the cost. So this code is written from the prompt caching. You can see the same code. We are using the caching in the .NET, right? So only the prompt in the class name. What is parallel agent? Now it is individually executing 111 and contacting LLM. Now all will work simultaneously at the same time, and it will ensure by the task dot when all that whether it's executing at the same time or not. So total latency become only one execution time. Streaming response, so LLM when come with the responses, so you know that LLM return full responses. Sometimes streaming allows token to be returned in real time. Benefit: faster, perceived, better user experience, interactive. Streaming is commonly known used in the chat system. Token optimization. So if the prompt is too big and everything, we need to check out that, so LLM cost and everything. So you can put some logic kind of thing, and you can reduce the token uses. Optimizing the architecture. So architecture use of general architecture is user agent, prompt cache. We are using parallel agent, LLM streaming. So whatever we discussed, right? Prompt cache, parallel streaming, optimizer, and final the response. Overall purpose is speed, improvement, and cost efficiency. So output will look like this: security agent or complexity agent. So we will show in the demo here we are using the three agent which will work parallelly: security, complexity, and the code review. So benefit is faster response, lower token cost, better scalability, improve user experience. User experience is the UI not get stuck. So a larger AI platform use additional optimization technique. We can use distribution caching, balance LLM request, asynchronous pipeline. So these are high level thing which can be into load balancing for faster performance. So these are the enterprise level that we are not using right now, but you can use it for the big applications like load balancing, asynchronous pipeline, distributed caching. This will scale to the million of requests. So key takeaways: AI performance optimize, reduce latency. Same thing we have discussed, but only the header is different. Performance architecture, we already discussed the same thing. Project architecture now. So we have the agents. You have seen in the earlier days also. Now we have a three agent. Performance, what are the KPIs we will check? Performance monitors, prompt catchy, parallel executor, token optimizer, and stream handling. The four we already discussed what individual actually carries in terms of information. Agent result will be come up. Order service means actually the code file on which these all things will work. So now the architecture, how the runtime architecture will work. So we have added a runtime architecture. Agent runtime will be called. Tasks, the tasks will be planned. The router will be there. A parallel executor. So this part is nothing but we have taken additionally for better architectural prospect. This thing you already know: prompt, catch, LLM, response aggregator, and final result. So more detail user request token optimizer will work. Trim code or reduce. So we will show the same thing in the code also. Then the prompt catch layer will work. Agent runtime will, so once the prompt part is done, then agent runtime will be activated. Agent runtime will check task planner which require agents. Then agent router which will select the agent dynamically. We have three agents, and then it start executing one by one or parallelly. Sorry. Once this execution is done, it will contact LLM internally. It will return the response in the streaming format. Then all the result from these three for this all three agent will be aggregated and final response. So these are the token based on the code, prompt cache, parallel execution, streaming response. So overall, what we are using right now, multi-agent system, supervisor pattern, we already discussed, routing, parallel execution, caching, runtime orchestration. So it is like a real AI framework. So those who are working on the LangChain, CrewAI, Azure AI Foundry, they will get some similarity like Agent Executor is nothing but your LangChain framework. You can just correlate. Runtime is like a CrewAI. We are using runtime also. We are using Executor also. Orchestrator, we are using Foundry. We will use the Foundry later. And the tool runtime. So let's go to the demo that based on this diagram. Just see this is the request. The same thing will be executed in the code using still Olama. We can take the cloud code also, but we are not using the cloud code, so we have removed in the day 15. So now let's run it to understand the sequential flow. Just see how it is being executed one by one. Architecture you can change based on your understanding. So whatever I have developed that is for understanding, but it is not an absolute one. So prompt cache. What is prompt cache? This is the prompt cache that I already shown you. Now we will read the file. The file means that code file. You have got the file. Now we will call the token optimizer. So we'll pass the code and we'll take the token optimizer based on this logic. Now we are collecting all the agent details, code review, security and complexity based on the cache. Cache you already have the prompt, and this kernel. Kernel means semantic kernel. Now we will call the router. So first is router. So router, then initialized, then we will runtime will be initialized. Then we will call the runtime. Inside the runtime, we will call the router. The router we already initialized. What we will do? Now we are calling all the three agents together. You remember we have earlier we have done selection of agents by the user also. So all we have collected. So once we have taken all the agent details from the router through the runtime, then our runtime actually will hit individual agents. Okay, but before that, we are just getting a default logic. You know the problem. You know that even though you are using the parallel executor, so contacting Olama simultaneously may cause timeout kind of thing, because Olama is not that much capable to handle. So what we are doing, even though you are executing parallelly, but we will ensure that that Olama will be contacted one by one. Otherwise cancellation may come. So that's the reason the old code I have written that was actually having some issue, because even though parallel the Olama is not able to handle, because until and unless the first request has been completed, the second request cannot be taken. But in case of parallel, the second request jump in or comes to the LLM before the first request get ended, right? That causing problem. So now we will go inside the parallel executor. So what parallel executor? So all the three tasks we got. So now we are using semaphore. The reason for semaphore is that even though you're using the parallel execution, but Ulama required some control concurrency. Otherwise, if all the requests come together at the same time, the Ulama cannot handle it and it get cancelled. So that's the reason the semaphore has been. So this is not a part of any AI kind of activity. It's a normal multi-threading, or you can say the concurrency control code. So that is actually safer. Otherwise, it may happen that the requests get cancelled because all three requests jumping each other. So let's see how you execute. Generally, I'm doing a F10 F10, so it is taking time. I don't know it is getting again cancel or not. But if you cancel, we will directly run. But I'm just debugging it to let you know the how this agent execute, agent runtime, agent router, all three agents work together. Continue. So we are in the security agent now. Just check and we'll see. Again, it will be executed. Response also came. Now we are into the complexity agent, the third agent. So what we will do now, we will not debug it right now. You understood the code flow. Let's run it together. So, since I haven't recorded earlier, So I'm getting this error from the semantic kernel. I have to update the code or some, or maybe if I run multiple times, in some point of it will get executed. I will paste that output uh, into the videos comment section, because I have